What is a carburetor? A carburetor is a mechanical pressure-driven device that premixes atomized fuel and air in the correct proportions. The carburetor has been used in engines since the late 1800s. It has seen many improvements in design for better performance, decreased emissions, and managing different fuel types. What job does a carburetor do? The carburetor supplies the mixture of fuel and air to an internal combustion engine for sustained operation. The carburetor also has components for engine speed control. Engine speed is controlled by the amount of airflow that goes into the engine through the carburetor body. The carburetor also has internal systems that lets it operate at low speeds. It also allows it to operate at high speeds and tolerate transitions between these speeds. Frequently, the carburetor will also have a choke or primer type of system that lets the engine start easier. Briggs and Stratton carburetors are frequently assembled from materials that include different features and configurations. However, they all operate on the same theory of operation: Bernoulli's principle of fluid flow applied to carburetors. To make a carburetor function, it is necessary to leverage the help of atmospheric pressure. This is where Bernoulli's principle is applied. Bernoulli's principle claims that as the speed of a fluid increases, the atmospheric pressure decreases on that fluid. The air that goes into a carburetor is applied as a fluid. A practical example of Bernoulli's principle is used to let an aircraft to fly. The primary edge of the wing, which is rounded and wider than the rear edge. This shape causes the air over the top to move faster than the air that moves under the wing. Lower pressure above the wing is the result of this design. The higher pressure under the wing tries to get at the lower pressure above it, but the wing structure is in the way. The higher pressure simply pushes equally on the full surface under the wing. This powerful force will lift the aircraft. How is an aircraft wing related to a carburetor? In the carburetor body, there is a passageway that narrows from one end to the other. This feature is known as venturi. If you compare a cross-section view of an aircraft wing and a carburetor venturi, you will then notice the two are almost the same. The venturi is built the same as a wing on the top and the bottom that makes a narrow passage for airflow. If you put a tube in the venturi, you can leverage the lower pressure to move fuel into the air stream. This is the same if you were to use compressed air across a straw and put it in fluid. The result is fluid movement and atomization of that fluid. It is important to make note that carburetors can have different forms of venturis. The area between the edge of the throttle plate and the carburetor body is a form of venturi. This assists with low engine fuel speed delivery. Carburetor components. Carburetor body. The body of the carburetor has been made from many materials over the years. The most common types are made from zinc and aluminum. These materials were readily available. They are easy to cast into rough shape and machine the features. The cost of aluminum and zinc have remained close over the years. The most cost-effective element or mineral at the time was the chosen material. Today, the practical choice is cast aluminum for modern metal body carburetors. High-density and reinforced glass carburetors have also become a very effective solution in recent years. Plastic carb bodies have been around since the 1970s, but suffered from a lot of inconsistencies until recently. These modern carburetor bodies are inexpensive and simple to manufacture because they use one body. The upgrade paths are easy. Airflow controls. Built into the carburetor is a throttle plate that turns on a throttle shaft. It is a type of airflow control that adjusts the engine speed. In most cases, it is connected to the governor system. The throttle shaft and throttle plate turn between almost closed and wide open. A 90-degree movement in total. The throttle plate physically prevents how much air and fuel can go into the engine. More restriction results in lower engine speed. Less restriction lets an increase in engine speed. The other type of airflow control in some carburetors is a choke plate. This is not standard on all carburetors. The choke plate is attached to a choke shaft and turns between closed and open positions. The choke plate's primary job is to assist with cold engine startup. When the choke plate is closed, it prevents airflow into the carburetor and increases the amount of vacuum in the carburetor. This results in more fuel to be delivered for a faster cold start. Fuel inlet controls. In order to give sustained engine operation, it is necessary to keep a continuous supply of fuel in the carburetor. Fuel will be supplied from a remote containment source. A fuel tank is attached to the equipment or directly to the engine. A fuel line will move the fuel from the tank to the carburetor body. Frequently, a fuel shutoff valve is put between the fuel tank and the carburetor. This valve stops the fuel flow for transportation or during long-term storage. The fuel goes into the carburetor body. It moves through an inlet needle and seat before it fills a bowl area in the bottom of the body. A float operates the needle and seat, which controls the level of fuel in the bowl. Circuits. In order to get fuel where it's necessary, there are circuits. These circuits are built into the carburetor body. They are frequently cast into the body in rough shape and then machined. Depending on the carburetor design, there will be two different circuits found: idle and high speed. Fuel metering. When fuel is supplied to the engine through the circuits, a restriction is necessary. This restriction is called a jet. The jet hole size is calibrated to the engine's requirements. Frequently, there is a jet for high and low-speed circuits. Venting and air bleeds. To keep fuel delivery constant for longer periods of time, a vent is necessary for the bowl area. This vent lets atmospheric pressure into the bowl area to help the fuel move into the circuits. There are two different types of vents: internally vented and externally vented. Internal vents means the vent is in the carburetor body and usually near the air-filtered area. External vents means the vent is on the external body of the carburetor. The two designs do the same work. One of the two designs is selected by what the engine's intended use is for. High and low-speed fuel circuits use air bleeds. Air bleeds are one more type of restriction, like a jet, but they only meter air. Air bleeds are calibrated to let air go into the fuel circuits to start the atomization process before the fuel goes out of the fuel circuits. This process makes the fuel supply consistent and engine performance better. Fundamental carburetor construction. To better understand how the carburetor operates, we will build a model. We will add the necessary components in order until we have a carburetor that will let an engine operate. The foundation of all carburetors is the body. In this example, our basic carburetor body will have some of the core components. These core components are a mounting flange to attach the carburetor to an engine. It also has a pathway from front to back for airflow. Lastly, it has a fuel inlet port, which will be used later. The venturi is in the carburetor's airflow passageway. The venturi uses Bernoulli's principle. It increases the airflow speed and makes a pressure change. The main nozzle is in the center post of the body. The end of this nozzle is in the center of the venturi where the fuel will be supplied during most conditions. The next feature added is the atmospheric bowl vent. The bowl vent is found in the front area of the carburetor when internally vented. Externally vented carburetors have bowl vents near the mounting flange. The bowl vent is a pathway. It lets atmospheric pressure go into the bowl area and be applied to the fuel. These vents are often baffled so that the fuel will not cause a blockage of the vent. Without a bowl vent, fuel is supplied to the engine for a very short time. Fuel supply circuits for high and low speed are added to the carburetor. The high-speed circuit is the main nozzle on this carburetor. The low-speed circuit passageway is built into the center leg of the body and moves fuel to a chamber. When you look at the main nozzle, notice the smaller holes around the outer diameter of this tube. These holes work together with the high-speed air bleed passageway. The idle circuit has an air bleed as well. In the idle circuit is a chamber that supplies fuel to the throttle plate area for idle operation. Also in this chamber are transition ports. These ports help supply more fuel when the throttle plate transitions from low to high engine speed. This chamber has a Welch plug on the outer body. Immediately below the main nozzle is the main jet. This jet is calibrated to the engine to control the amount of fuel supplied to the main nozzle. This jet can be a component by itself or part of the bowl nut. The idle circuit also contains a jet. The jet can be a component by itself or part of a pilot jet. A pilot jet contains the air bleed meter and the fuel jet in one component. Because the primary fuel supply features have been included, a throttle shaft and throttle plate can be added for engine speed control. This plate turns from fully closed to fully open in a 90-degree movement. Next, a choke shaft and choke plate can be added to the carburetor to help with cold startup performance. Remember, some carburetors do not use a choke plate. Carburetors without a choke plate will frequently use a primer bulb. This helps enrich the carburetor venturi area with liquid fuel for a cold start. The primer bulb momentarily causes a blockage to the bowl vent, pressurizes the bowl, and pushes the fuel up the main nozzle. The last area of carburetor construction is the fuel level management system. In the bowl area, an inlet needle and seat is below the fuel inlet. The needle and seat have a pair of tapers that stop the fuel flow into the bowl. The needle has a rubber tapered tip, and the seat is made from a hard material. A float helps manage the fuel level in the bowl. In most modern carburetors, it is made from plastic. The float pivots on an axle pin and is attached to the needle by a groove or a clip. As the float falls, the weight of the float pulls the needle down and lets the fuel go into the bowl. The bowl will fill until the float gets to a certain position and will operate the needle to stop the fuel flow. Here we have assembled a fully operational carburetor that would let an engine operate correctly. With the knowledge we learned, let's take a look at carburetor circuit operation. Let's start with the idle circuit. It is important to know not all carburetors have idle circuits. These types of carburetors are used in smaller machines like lawnmowers. The fuel source for the idle circuit is metered 2 times. The first stage is through the main jet in the center leg or bowl nut. From here, fuel is pushed up a drilled passageway in the center leg and through the second meter jet. The fuel then intersects with the idle air bleed circuit. Immediately before this intersection, the air that went into the air bleed was also metered. Atomization starts at this intersection. Sometimes a pilot jet is at this location. The pilot jet includes the second idle fuel jet. Also, metered air goes into the air bleed passageway. As the mixture moves, it atomizes. The mixture will move to the chamber area to supply fuel for low-speed engine operation. While the throttle plate is almost closed, a venturi comes into shape between the edge of the throttle plate and the carburetor body. the idle fuel supply port is at this location. The transition ports are also immediately behind the idle fuel port. The transition ports supply auxiliary fuel when the throttle plate starts to open. This function creates seamless engine speed changes. The high-speed circuit is more direct. When the throttle plate opens, the airflow in the carburetor will increase. The venturi will make the necessary pressure change to move the fuel. In the bowl area, the fuel is metered only one time through the main jet. The fuel is pushed up the main nozzle and starts to atomize immediately. The high-speed air bleed circuit supplies the holes in the outside of the main nozzle with air for this mixture process. The high-speed circuit will start to supply fuel when the throttle plates start to open from 25% and remain active to 100% throttle open. During normal operation, the idle and high-speed circuits will supply fuel at the same time. Only when the throttle plate is less than 25% closed or more than 75% open will it operate on an independent circuit. It is important to know that the two circuits that do the work together supply the total amount of fuel to the engine. This comprehensive look at carburetor design and theory applies to many different types of carburetors. With a better understanding of how carburetors work, it's easier to understand how to repair and service carburetors.